Hi, my name is Basir. In the previous video, we learned how to find out roots of a quadratic equation using factorization method. And in this video, we'll learn how to find out roots of a quadratic equation using method of completing the square, and also how to find out roots of a quadratic equation by using quadratic formula. Now, the reason that we have these two other methods is that it is not always practically possible for us to find out roots of a quadratic equation using factorization method. For an example, let's say we have this quadratic equation: x square plus 4x minus 4 is equal to 0. Right, x square plus 4x minus 4 is equal to 0. Let us try and see if we can factorize this quadratic equation using the factorization method. So in factorization method, this is what we usually do. We just multiply the coefficient of x square with the constant term, which is 4. 1 into 4 is 4. Now if I add these two numbers, or if I subtract these two numbers, I should get the coefficient of the middle term, which is 4x, right? 1 plus 4 is 5. 4 minus 1 is 3. No, I'm not getting 4. But then we can pretty much do this. 4 goes in other tables also, right? 4 goes in 2 table also. 2 2s are 4. Now if I add these two numbers, I'm getting 4, so we are good. 4x, I can write it as 2x plus 2x. So instead of 4x here, I'm splitting that into 2x plus 2x. We'll have to take common from the first two terms and something common from the last two terms. If we take x common from the first two terms, we end up getting x into x plus 2. From the next two terms, I can take 2 common, because 2 and 4, this 2 and this 4 here, they both go in 2 table, right? And when I take 2 common, I get x minus 2 here. Now these two terms here are not equal. This is x plus 2 and this is x minus 2. They both are not equal, so we won't be able to proceed with the factorization method. So for reasons like this, where we cannot find out the root of a quadratic equation using factorization method, we have a fallback method, method of completing these squares. Let us go ahead and learn this method of completing these squares. Now let us try to find out how to find out the the root of this quadratic equation using method of completing these squares. We saw that we were not able to find out the square root of find out the root of this quadratic equation using the factorization method. We'll now see if we can find out the root of this quadratic equation using the method of completing these squares. Method of completing these squares is quite simple. All you have to do is you just need to make sure that you move the constant term to the right hand side first. So minus 4, if I take it to the right hand side, it becomes plus 4. Once you move the constant term to the right hand side, also you have to make sure that the coefficient of x square always remains 1. The coefficient of x square should always be 1. So that's the second criteria. Okay, so there are two things that you need to start with. The first things first, coefficient of x square should always be 1 when you are working on method of completing these squares. And then the second thing that you got to do is you need to move minus 4 to the right hand side, the constant term to the right hand side. Okay, once you do that, the left hand side you have to make it as a perfect square. Now what is a perfect square? 4 is a perfect square, 9 is a perfect square, 16 is a perfect square, 25 is a perfect square. Why? Because 4 I can write that as 2 square, 9 I can write it as 3 square, 16 I can write it as 4 square, 25 I can write it as 5 square. So if I can write, if I can convert the left hand side into the form of a square, then it pretty much means that I have converted the left hand side as a perfect square. Okay, doesn't make sense? No issues. Let's go ahead and work on it. Now this left hand side will convert that into this form: a square plus 2ab plus b square. A square plus 2ab plus b square. What is a square plus 2ab plus b square? It is a plus b whole square. So this way we'll convert the left hand side in the form of a square. Right, this way we'll convert it into the form of a square. Now right now we only have a square plus 2ab term, we don't have b square term. So this is what we have to do. This is my a square, this term is 2ab, 2ab, or else let me write it this way: 2 a is x here, we can see here a is x, 2 a, in place of b I can write 2 here, because 2 into 2 is 4. So now I have this in the form of a square plus 2ab, but I don't have b square. The value of b from here is 2, so we have to add b square here. If we add 2 square on the left hand side, we have to add 2 square on the right hand side too. So now this left hand side is in the form of a plus b whole square. You can see here a square plus 2ab plus b square. This is the form of a plus b whole square. 4 plus 2 square is 4. X plus 2 whole square is equal to 4 plus 4 is 8. Now left hand side you converted it into the form in the form of a perfect square, right? You have a square here. Now if you remove square from the left hand side, you will have to put a square root on the right hand side. You can consider this as plus or minus root 8, or else root 8 I can do it this way also. If I take LCM of root 8, I get 2 into 2 into 2, because 2 into 2 is 4, 4 to the 8, right? Now these two same terms I can take it as one outside, take it, and then this 2 remains inside the root itself. So value of x is plus 2. If I take it to the right hand side, it becomes minus 2. So now we have two roots. One is with the plus sign. So this is how we read it: x is equal to minus 2 plus or minus 2 root 2. So one of the root is minus 2 plus 2 root 2, and then the other root is minus 2 minus 2 root 2. So we consider plus for the first root, and then when we consider minus, we get the second root. So we now have two roots for this quadratic equation, right? So we were able to find out the roots of this quadratic equation using method of completing squares. Now if you find any difficulty here in finding in understanding how I added b square here, this is quite simple actually. 2 2s are 4, so b is 2. I can understand it this way, but maybe there could be people who don't understand this. For them I'll show you explain you this thing in a slightly different way. Let's go ahead and try to do the same thing all over again. X square plus 4x minus 4 is equal to 0, right? X square plus 4x minus 4 is equal to 0. Let's try to do the same method of completing these squares by using a slightly different logic here. X square plus 4x plus 4, if I take it to the right hand side, it becomes minus 4. If I take it to the right hand side, it becomes plus 4. Now I have added here 2 square, right, on the left hand side and on the right hand side. To find out what has to be added, you just need to calculate this thing here: half b by a whole square. This has to be added. Simple. You can convert this quadratic equation with the general form of quadratic equation, which is ax square plus bx plus c. So now you know that the value of a is 1, value of b is 4, value of c is minus 4. So we'll just do this, substitute this thing here. B, value of b is 4, so in place of b I'm writing 4. In place of a I'm writing 1, value of a is 1 here, whole square. 2 ones are 2 twos are, so what do I get here? 2 square. So this is what I have to add on left hand side and the right hand side. Simple. So if you want to know what you have to add on the left hand side and the right hand side to make this left hand side a perfect square, you just need to calculate this thing, half b by a whole square. Post this, everything is just the same. This left hand side has now become a perfect square, so it is in the form of a plus b whole square. Everything is just the same. So I wanted to show you that you can pretty much easily use this thing, half b by a whole square, to know what has to be added on the left hand side and the right hand side. Let me go ahead and show you one. You will go ahead and do one more problem here. Using method of completing squares, we will find out the root for one more quadratic equation. Just so you get a gist of what it takes to solve a quadratic equation using method of completing squares. Okay, there we go. Here we have one more equation. 3x square minus 5x plus 2 is equal to 0. 3x square minus 5x plus 2 is equal to 0. Same thing, we'll try to find out the roots of this quadratic equation using method of completing these squares. I told you in the very beginning, you have to make sure the coefficient of x square should always remain 1. Here in our case the coefficient of x square is 3, so to remove 3 I'm going to divide this complete equation by 3. The left hand side and right hand side, I'll completely divide that by 3. This 3 and this 3 gets cancelled. I get x square minus 5 by 3x plus 2 by 3, 0 by 3 is 0. So now the coefficient of x square is 1. While working on method of completing squares, we always have to make sure that the coefficient of x square should always remain 1. Now the second thing that you do is you move the constant term to the right hand side. So plus 2 by 3, if I take it to the right hand side, it becomes minus 2 by 3, right? Now I want to find out what I should be adding on the left hand side and the right hand side. To find out what should be added on the left hand side and right hand side, you can pretty much find this out. Half b by a whole square, you can calculate this. Half b, what is b here? I'll use the original equation that was given. Original equation that we had was this one. Let me compare this original equation with ax square plus bx plus c is equal to 0, which is general form of quadratic equation. Value of a is 3, value of b is minus 5, value of c is 2. Let me substitute it here. Value of b is minus 5 by value of a is 3 whole square. If I square a given term, this minus will again get converted to plus, right? Because 2 is an even number here. This minus will always get converted to plus, so there's no need of taking this minus sign. 1 by 2 I have to multiply by 5 by 3. 1 into 5 is 5. 2 3s are 6. So 5 by 6 whole square is what I have to add on the left hand side and the right hand side. That's about it. Let us go ahead and add 5 by 6 whole square on the left hand side and let us add 5 by 6 whole square on the right hand side. This left hand side, once you add 5 by 6 whole square, it gets converted in the form of a plus b whole square. Here a is x and b is 5 by 6. We have minus sign here, so it gets converted into the form of a minus b whole square. Now let us just simplify the right hand side. Minus 2 by 3 plus 5 square should be 25, 6 square should be 36, right? X minus 5 by 6 whole square is equal to, let us take LCM. The LCM of 3 and 36 is 36. 3 12s 36. So up in the numerator also I am going to multiply that by 12. 36 1s are 36. So numerator also I am going to multiply by 1. 12 2s are 24. 25 1s are 25. 25 minus 24 is 1 by 36. X minus 5 by 6 is equal to, if I remove square from the left hand side, I'll have to put square root on the right hand side. X minus 5 by 6 is equal to, square root of 1 is 1, square root of 36 is 6. So I get plus or minus 6 here. Plus or minus 1 by 6. Minus 5 by 6, if I take it to the right hand side, it becomes plus 5 by 6. Now I should actually be getting two roots, right? Because it's a quadratic equation. A quadratic equation is a second degree equation, right? The power of the quadratic equation is always 2. The degree of the quadratic equation is always 2, which means we should be getting two roots. Now I'll take plus 1 by 6 as the first root, and then I'll have to consider minus for the second time. So once I'm taking plus 1 by 6, plus 5 by 6 I'm writing as it is. Second time I'm taking minus 1 by 6, plus 5 by 6 I'm writing as it is. LCM of 6 and 6 is 6. 1 plus 5. LCM of 6 and 6 is 6 minus 1 plus 5. 1 plus 6 is 6. 5 minus 1 is 4. 6 1s are 6 1s are. 2 2s are 2 3s are. X is 1. X is 2 by 3. So we got the roots of this quadratic equation. We got the roots of this quadratic equation. As simple as that. I believe you guys should be having some kind of idea with regards to finding the roots of a quadratic equation using method of completing squares by now. We'll now go ahead and find out how to find the roots of a quadratic equation using quadratic formula. Let me select a new document here. This document is almost full here. Okay, let us find out the roots of this quadratic equation, the same quadratic equation, using another method known as quadratic, using quadratic formula. Now, quadratic formula is minus b plus or minus square root of b square minus 4ac by 2a. That's our quadratic formula. We have to compare the given equation with the general form of quadratic equation, which is ax square plus bx plus c is equal to 0. Value of a is 1. So here the value of a is 1. Value of b is 4 and the value of c is minus 4. Right. Before we start making use of the quadratic formula, we will have to find out the determinant or the discriminant. This b square minus 4ac is known as the discriminant. So let us first find out b square minus 4ac. If b square minus 4ac, if the value of b square minus 4ac is greater than 0, then we get real roots. We can go ahead and make use of the quadratic formula to find out the roots of a quadratic equation if the value of b square minus 4ac is greater than 0. Let me substitute the values of a, b and c here. B is 4, a is 1, c is minus 4, 4 square is 16, minus into minus is plus, 4 4s is 16, 16 plus 16 would be 32, and 32 is greater than 0. So I can make use of this quadratic formula to find out the roots of this quadratic equation. Now let me substitute a, b, c values in the quadratic formula. This is our quadratic formula. Minus b plus or minus square root of b square minus 4ac by 2a. Minus b, what is the value of b? The value of b is 4. Plus or minus square root of b square, what is the value of b again? 4. 4 square minus 4. In place of a I am going to substitute 1. In place of c I'll have to substitute minus 4 by 2a. Value of a is 1. Minus 4 plus or minus square root of 4 square is 16. 4 4s is 16. Minus into minus is plus. 4 4s are 16 by 2 1s are 2. X is equal to minus 4 plus or minus square root of 16 plus 16 is 32 by 2. Let me just make use of this space to solve the rest of the problem here. Now 32, we'll have to take the LCM of 32. When you take LCM of 32, you see that you can write 32 as 2 into 2 into 2 into 2 into 2, right? 2, if we multiply 5 times, we get 32. X is equal to minus 4 plus or minus. These two same terms I can take it as 1 outside the square root. These two same terms I can take it as 1 outside the square root, and inside the square root I end up getting only 2, right? X is equal to minus 4 plus or minus 2 2s are 4. 4 square root of 2 by 2. Now this 2 I can distribute it. This 2 goes under, it divides minus 4 also, and it divides 4 root 2 also. 2 1s are 2 2s are 2 1s are 2 2s are. So this is what I get here. X is equal to minus 2 plus or minus 2 root 2. So once I'll take plus, consider plus, and then second time I will consider this minus sign. So these are our two roots. X is equal to minus 2 plus 2 root 2. X is equal to minus 2 minus 2 root 2. So we have learned two new methods here for finding the roots of a quadratic equation. The first is method of completing the squares, and the second that we went through was using a quadratic equation for finding out the roots of a quadratic equation. In the next video we'll go ahead and work out exercise 5.3 problems. So until then, goodbye.